Alright guys, it's Mr. Lynch, lesson 2.2e. Let's get going on this. We're looking at more representations of a linear context. So, as always guys, before we start, make sure you like, make sure you subscribe, and make sure you are ringing the notification bell so you guys can see these videos as soon as they come out. So, what we're doing in these problems is we're going to be given one of the representations, so either a context, a table, a graph, or an equation, and we need to fill out the other three from that. And so in filling out the other three from that, let's look at the first problem, the state fair. You and your friends go to the state fair. It costs $6 to get in and $2 each time you go on a ride. So what that means is that our unit rate, or how much it increases each time we go on a ride, is 2. That is our unit rate. So over here in our table, let's go, let's go number of rides. We'll put rides up here, and we'll put dollars here. So on 0 rides, we had to pay, well, we didn't pay 0 because we had to get into the fair, which is $6. So 0 and $6. Now if we ride 1 ride, we increase this, we add 2 because we went up, we did 1 ride. So that's $8 that we've spent. 2 rides, we add another 2, which gets us to $10. 3 rides is 12, 4 is 14, 5 is 16, and 6 is 18. So we have a context, we have a table. Now we need to graph. Let's graph this. So this is our y-axis, this is our x, this is our number of rides, and this is our money. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can go by ones on each of these. So that's 1. Actually, I'm going to get rid of that. I'm going to call this. So here's 0, 2, 4, 6, 8, 10, 12, 14. 1, 2, 4, 6, 8, 10, 12, 14. So at 0, we were at $6 already spent. At 1 ride, we were at $8 spent. 2 rides is $10 spent. 3 rides is $12 spent. 4 rides is $14 spent. And we can see we have this nice line coming in here now. This is one thing where I'm kind of, I don't know how to tell you guys this, but we cannot fill in the line here. Okay. It wants us to, but we physically cannot. Because is money just constantly disappearing from your pocket? No, you're paying $2 at the beginning of each ride. Well, if we were to draw a line, that would mean that this right here were a solution. So we could plug in, we've gone on 1.25 of a ride and we paid $8.75 or whatever it is. That doesn't work. So we're going to leave it how it is. Our equation, so let's call money M. So our amount of money is equal to $2 for each ride. So 2 times R, so R for rides, plus the initial $6 that it cost to get in. Does that make sense? I hope so. Let's look for one that has the equation given to us because I want to see what they wrote. Oh, they just did y equals 4x. Okay. All right, we'll change it. We're going to call this y equals 2x plus 6. And that is the equation for this line, or for this graph in this table. So the rate of change, or the unit rate, is 2. And in this context, it is $2 per ride. What is the y-intercept? Now, the y-intercept is a really cool thing here, guys. The y-intercept is where it crosses the y-axis. All right, so y-intercept is where we cross y-axis. Okay, so it's that point on the y-axis. How can we change the context so that the relationship between total cost and number of rides can be modeled by y equals 2x? Well, if we wanted to do that, we would have to get rid of this plus 6, which means the fare would have to be free, a free fare. How can we change it so that it could be y equals 6? Well, in order for that to happen, the rides would have to be free. We would have to get rid of that changing amount. All right, I'm not going to do the road trip because you guys can do this one, but I will tell you guys, you will fill in the line. All right, I want you guys to do this one because it gives you the context, just like we had in that first problem. You guys got that one. So now we're given a table and a graph. All right, we're given a table and we need to find everything else. So I'm going to say that our y-intercept here is 7. So what we're going to have to do is we're going to have to add 7 on to our equation. Then I'm going to look over here and I'm going to say, okay, that's a plus 2. That's another plus 2. So it looks like our rate of change is 2. So I'm going to go 2x. Y is equal to 2x plus 7. Now that I know this, I'm going to start plotting over here. I'm going to go up 7. So 1, 2, 3, 4, 5, 6, 7. 7 is right here. Now, because I can do this 2 different ways. I can either come back down, go over 1, and go up to 9. Or, because I know my rate of change, I can go from where I'm at, and I can draw a triangle that's 1, 2. So then I'm going to go over to 2 and go to 11. 3 is at 13. And 4 is at 15. Now, if I want to draw in my line, I have to make sure my context allows for that. And I do want to draw in my line. So I need to make sure my context allows for that. So let's say, this is the cost of an Uber, because that's constantly going up. So we're going to say Uber charged me $7. Each hour is $2 more. There we go. So Uber charges you $7 to get in, and then every hour is $2 more after that. That would get us this graph, and it would get us this line, because the amount is constantly going up. It's constantly changing when you're in that Uber. Because as time is increasing, this is increasing. The rate of change in this problem is 2 again. Our y-intercept, we look for where x is equal to 0. In our table, when x equaled 0, y was equal to 7. And how would your context change if the rate of change was 3? Well, then it would be $3 an hour, not $2 an hour, which really wouldn't be all that bad. All right, so now we're given a graph, and we need to fill everything else out. So just looking at this, do you guys think it's going to be positive or negative rate of change? I think it's going to be a negative because we're moving down and to the right. So that looks like a negative to me. It looks like we're decreasing. So I'm going to start in the table. And I would always start with x equals 0. Y has to be 100. And I'm going to come over here to 2. Well, 2 is 90. 4 is 80. I'm going to assume that 6 is at 70. Let me double check because I see a pattern. Yeah. So every 2 increase in x gets us a 10 decrease in y. So 8 is going to be 60, 10 is going to be 50, and 12 will be 40. Let's double check. Yep, 12 is 40. So as this increases by 2, this decreases by 10. Now, one way we can find our rate of change, so our rate of change, is by taking this change in our y's. So this change, our rate of change here was negative 10, and dividing it by our rate of change in our x's, which is 2. If we take this and divide it, if we simplify this, that gets us negative 5 as our rate of change. So as we move over 1, we come down 5. So then our equation is y equals, take our rate of change times x, negative 5x, and we look to see where x equals 0. So when x equals 0, y is 100. And a context, I'll let you guys create a context, but just know that it needs to be decreasing. It must decrease. If it is not decreasing, then your context does not fit with this equation. The rate of change in this problem is negative 5. Our y-intercept is where x is equal to 0, or we cross the y-axis, which is 100. How would your context change if the y-intercept of the graph was changed to 75? Well, that's something you guys need to look at. How would this change affect the graph? So if our y-intercept was changed to 75, that'd be right here. We would be, let's see, where do we hit 25 at? Right here. This would be at 0. This would be our line. So we'd be shifted down, and it would really change the context. So if we changed our rate of change from a negative 5 to a negative 2, would the new line be steeper or less steep? Let's think about that. If we change it to negative 2, then, well, if we want to put it back up in here, we'd have to make it something divided by 2 is equal to negative 2. Well, if we multiply both sides by 2, we get that x has to be negative 4. So instead of 10, we would only be decreasing by 4, which would mean it would be less steep. So at 2, we would have 96, 92, 88. So you can see this is a less steep line because we're reaching higher and we're having higher y values than we would with the original. So it becomes less steep. All right, and then the last problem is we're just given an equation. So let's fill out this table. I like to start with x equals 0. Right, that's a good place to start. So in order to do this, whenever I see x, I'm just going to plug in 0. So 4 times 0 is 0, plus 10 is 10. I'm going to erase this. Now when x equals 1, 4 times 1 is 4. 4 plus 10 is 14. 4 times 2 is 8. 8 plus 10 is 18. And if you guys are starting to see a pattern, we add 4 there. We add 4 there. We're going to add 4 here as well. So that's going to be 22, 26, 30, 34 as we increase by 1. So when doing this, let's look at our graph now. We have our table. Let's look at our graph. Oops, what is going on here? Wow, that was really bad. Sorry, guys. All right, let's look at our graph. And actually, I want to come down a little bit. Okay. So at 0, we're going to be up at 10. So 2, 4, 6, 8, 10. That's not really going to work for me. So let's go by 2s. So 2, 4, 5. So we'll say 10 is right here. Which means that 14, that's 10, 12, 14, is going to be here. 18 is going to be here. 22, 26, 30. And we can draw in this line as long as our context supports it. So not talking about money, but talking about maybe filling up a pool with a hose or driving. Something like that would work for this. But money doesn't work as well. So guys, create your context. You got this. As always, guys, I hope you enjoyed the math. Make sure you hit like, make sure you subscribe, make sure you ring that notification bell, and we will see you guys next time.